right angles, which are 90 degrees. 90-degree corners are found everywhere in buildings, against walls, in doorways, on the floor. Sometimes in the real world, two angles join together to form a right angle. Other times, two angles join together to form a straight angle. These two angles together form a right angle. We call them complementary because when you add them, they equal 90 degrees. This step is a great example of two angles that form a straight line. These two angles are called supplementary because together they add up to 180 degrees. It's confusing because complementary and supplementary sound alike. I have 3 ways to help you remember them. Don't feel like you have to memorize all 3 ways. Pick the one that makes the most sense for you and remember that one. In the alphabet, the letter C for complementary comes before the letter S for supplementary. And in a number line, 90 comes before 180. So C complementary goes with 90 degrees and S supplementary goes with 180 degrees. A corner is a 90-degree angle, and a corner is complementary, C for C. A straight angle equals 180 degrees, and supplementary angles are straight angles, S for S. Supplementary angles add up to 180 degrees. The word complementary has 1 P in it. If I take that P and turn it around, it looks like a 9. Put a 0 on it and it's 90. Complementary is 90 degrees. The word supplementary has 2 P's in it. Turn those P's around and they're 9. Add your zeros to the end. 90 plus 90 equals 180. Supplementary angles add up to 180 degrees.
Okay guys, so that was just a brief video talking about complementary and supplementary angles. Pardon my arm there. And I wanted to show that video because I think you guys have heard of it before, but just a quick reminder. Ooh, hang on.
Supplementary, complementary, vertical.
You guys want to watch that again, don't you? I know you're so excited. Pardon me for that. But yes, talking about complementary and supplementary angles, that's important information that I'm assuming you guys are okay with. There are 3 ways to remember it. Feel free to use them, okay? 2 lines are perpendicular if they intersect to form a right angle. Again, we talked about this in class, but if you have a box here, this is a 90-degree angle, and we refer to that as perpendicular. This upside down T is read as perpendicular to, which I've just showed you in class a few times as well. Just be comfortable with it. And a blank is a line that intersects the plane and a point and is perpendicular to every line in the plane that intersects it. A line perpendicular to a plane is a line that intersects the plane. So basically, if you have a line that's perpendicular to a plane, every single point you draw through there, or line that intersects with it, will be 90 degrees. Okay? And I'll show some pictures of that in class as well. Down number 1, use diagram to determine whether the statement is true or false. So we're just saying true or false here. Points A, B, and C are collinear. When you hear the word collinear, you're going to hear in class collinear and coplanar. They're just points on the same line or on the same plane. So A, B, C is right here. Can I take my pen and drop it so that all 3 of these points are on the same pen? What do you guys think? Hopefully you see that it is not. This is going to be false. Okay. DCB, boom, 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 which again, feel free to highlight if you'd like. And DCH are supplementary. Well, they're both 90 degrees. So 90 and 90 is 180, which is supplementary. This would be true. Okay, just like in that video we just watched. Points E, D, and H lie in the same plane. Now this is kind of a little bit out there, but E, D, C, alright, it's just 3 points. There was a postulate we learned, I think, in the previous set of notes. Any 3 points you have in the entire existence of the world are coplanar. They're all on the same plane. Any 3 points. The moment you have more than 3 points is when you start to have non-coplanar. Okay? So this would be true. DCB and ABC, DCB, ABC, they're both 90, so you might be inclined to say true here. However, Complementary means two angles adding up to 90, not 180, so this would be false. And lastly, point C is the midpoint of BH. Now, this is a tricky one. When you first look at it, C looks like it might be the midpoint of B and H. However, in order to say something is true, you must have something to back it up. Very important rule, okay? So just by looks alone, we don't have enough information. So we would say false here, and if you had to give a reason, it would just be not enough info, NEI, so on, okay? So make sure if you ever say something that you have evidence to back it up. All right, here's our next set of key vocab. A biconditional statement is a statement that contains the phrase if and only if. We saw this briefly in a previous note, so now we're going to talk about it finally. One other little thing, you might see me do this. If and only if, mathematicians in general like to do shorthand just because we like doing math more than like to write out sentences. So if you ever see me write out IFF, it just stands for if and only if. I'll try to write both, but if you ever see me just kind of do that because of creature of habit, just understand that's what it means. Writing a biconditional statement is equivalent to writing a conditional statement and its converse. Basically, a conditional is if something, then something, and the converse is you flip it, okay? The biconditional means that both of those statements are true. So let's take a look down here. The biconditional statement for number 2 is, well, it says rewrite the biconditional statement as a conditional and its converse. A ray bisects an angle if and only if it divides the angle into two congruent angles. So this first part is going to be my hypothesis. Here's my conclusion. So if a ray bisects an angle, then it divides the angle into two congruent angles. Okay? That's my conditional, my if-then. The converse, again, if you recall, I'm just taking my conditional now and I'm flipping it. If it divides the angle into two congruent angles, then the ray bisects the angle. Okay? So again, all a biconditional statement is, it's basically just taking your regular if-then sentence and turning it into an if and only if. Alrighty? Nothing too bad. And again, you might see me do this. I know I'm reminding you about this like twice, but I do use that a lot, so just a heads up. Okay? Wonderful. On to the back. Give a counterexample that demonstrates that the converse of the statement is false. Okay, so they're going to give us a conditional. If a polygon is a square, then it has 4 sides. That makes sense. But our converse is if it has 4 sides, then the polygon must be a square. Now here's where you have to think. Can you think of anything else that has 4 sides that is not a square? Okay? So your counterexample could be a number of things. You could put, CE by the way for counterexample, you could put rectangle, rhombus, parallelogram. Okay, because they all have 4 sides, but they're not a square. Alrighty? Next one, if you live in Orlando, then you live in Florida. Okay, the converse, if you live in Florida, then you live in Orlando. Okay, now think about that. Is there anywhere else in Florida you could live besides Orlando? Yeah, you could live in like Miami, Tampa Bay, wherever, okay? As long as you get something that's there. Cool. Number 4, write the converse of each statement, of each true statement. If the converse is also true, combine the statements to write a biconditional statement. If two angles are vertical angles and they are not adjacent, converse. If they are not adjacent, then two angles are vertical. Just to quickly show you this as well, here is two lines intersecting. Vertical lines are lines that are angles that are, vertical angles are angles that are across from each other. Just because they're not adjacent, okay, doesn't mean they have to be vertical. So this does not have a true biconditional, so you would just stop with your converse. Number two, part B, if an angle measures 30 degrees and it is acute, the converse, if an angle is acute, then it measures 30 degrees, okay? And if you think about this, does every single acute angle have to be 90 degrees? The answer is no. So again, there is no true biconditional. To give you guys a little heads up, it is extremely rare to have a true biconditional. They are difficult to get, alright? So don't be alarmed if you don't get them very often, alrighty? Number 5 down here, the last one we're going to take a look at. What kind of angle is this? Well, this box right here kind of tells it all. It's a 90-degree angle. So do you think that's complementary or supplementary? Hopefully we're thinking complementary, alright? So what we can do here is create ourselves an equation. Now I put this on here for a reason. I love these problems. You're going to see them time and time again. So take your two expressions, 2x plus 12 plus 3x plus 13, and set it equal to 90, alright? Please be careful. I see, common mistake is to say 2x plus 12 equals 90, 3x plus 13 equals 90, but they have to add together to get there. Combine like terms. 5x plus 25 equals 90. Subtract 25 over from both sides, again, where the equal sign's at. 5x equals 65. Divide both sides by 5. X equals 13. Now, just in good practice, check your directions again. Solve for x by following the picture. We did. It doesn't say solve for the angle measures, but it might. So just to show you, just in case, 2 times 13 plus 12, 26 plus 12, 38 degrees. And then 3 times 13 plus 13, 39 plus 13 is 52. 52 and 38, they do indeed add up to 90 degrees. We know we're good, all right? So there is a lot of logic involved with this. This is our final section for our chapter, all right? But what I want you guys to continue to do is think about the problems. Think logically through these problems, all right? A lot of these questions on this upcoming test will ask you guys things that, make you think about the situation, view it from different standpoints, and it's not as simple as just solving for x, but applying the knowledge that you've already acquired from years ago, okay? As always, if you have any questions, feel free to ask in class. And most importantly, good luck. We are all counting on you.